Hi and welcome to the lesson about the data enrichment. Data enrichment is one of many components of data cleansing jobs. And more specifically, it's a way to improve the data you are receiving with some external information. Why it's not possible to do at the source? So let's take our example of the pipelines we are currently working on in this course. So we have our producers API gateway, which is nice, gives some flexibility, and we have our internal data system and multiple data processing jobs consuming data in real time. So the problem with it is that the producers have only the local context, so they don't know anything about maybe the master data set for your data. Typically here we may have some kind of references for browsers, for devices. There is mostly the information available for the producers is an event. So when someone clicked on some link, it's the information about the link, maybe eventually the information about the referrals of the previous page, obviously the event time, so the click time, but typically that's all. And all the extra information is included, is present inside in your system. So there is technically there is a way for the producers to communicate with your system, but the producers never know what kind of data they need to fetch to fulfill your demands. And even they knew at now, maybe these requirements will change in the future. So certainly this requirement will change in the future. And what to do in that situation? In that situation, we fall back somehow to the problem we have discussed previously about having or not having this API gateway. And in the case of not having it, they need to change all the connection parameters here. So here there is exactly the same problem. We would need to update all the data enrichment part for the producers, which in some scenarios may not even be doable technically, because it would require forcing some updates not necessarily related to the user experience, which is not always welcomed by the end users. So that's why we have some data enrichment part as a component, as a part of the data cleansing. And how does it look like? So we have our data processing layer and data processing layer, data cleansing in our case. Besides preparing and formatting the data, it can also query other different places for more information about the data. So here we have some API with HTTP calls and databases with maybe JDBC connectors. And all this here is represented as our internal system, but of course you can also query APIs exposed by third parties, like, I don't know, maybe if you are consuming some social media data, you can, if it's possible, you can query their APIs as well as a part of the data enrichment scenario. And here it's open to you, it's open to the data you are working on. And that way our small data, small box that is coming got enriched, and there is much more information that is available to us, to our end users. And how this data enrichment is possible? So there is first case where the data enrichment is a simple join either between streaming data store or data addressed data store, and it's very often natively implemented in the data processing frameworks you are using to write these data cleansing jobs. On the other hand, it may also require some buffering, because imagine that you have some streaming data coming in here and this data doesn't have the same latency as the data available here. So typically in one or another case, we will need some buffering in order to maximize the probability of finding matches. And of course, there is also a small drawback of consistency. So again, for example, if our buffer is too small, we will miss some joins, and it's not always ideal. That's the reason why it's simpler to reason about this join in the context of data enrichment in terms of static dataset. Another possible implementation is a lookup table. So the lookup table is also an external storage, But the difference with the previous join scenario is that we are implementing this join mostly in the code part, in our code base, by making some API calls targeting specific keys that we would use previously in the join, but here we are making specific calls across the network. We are getting data from these keys, and hopefully we are also managing some local cache so that we don't need to make these queries too often. So here, remember, we have already discussed bulk and batch operations, and they will be your friend here because obviously you will reduce the number of network queries, and with the cache it could be somehow acceptable, even though latency can be a little bit disturbed by these network calls. But anyway, it's always specific per use case. So just to be aware that you will very probably make network calls, and it can impact your data processing latency. And the final part is the web service. So here again we have to make some code in our code base, but again we use some bulk operations if of course your web service provides them, and if you implement some caching logic you can save some space and probably not see the network cost. Even though you probably know it already, managing cache is very complex topic, and you will also, besides storing the data for some period of time, you will also need to invalidate it somewhere so that you can fetch the most recent entries from the web service, and it's not a trivial part, it's not a trivial task to do. And there is also some local solution, meaning that you have, for example, one wheel or one jar, depending on the language you are using, that you include directly into your processing logic so that all the enrichment data remains local, meaning that it's available either as files bundled in your project or maybe even in memory for very fast access. But on the other hand, it has much more drawbacks because there is very huge challenge to update these artifacts. You will probably need to redeploy the whole job, meaning that it will be probably stop of the world event during the update. And there is also some size limitations because of course if you put 5 gigabytes of a reference master dataset into some jar or wheel and you load it into main memory, where there is a big chance that your processing will fail because of the out of memory problems. So these are 4 different scenarios approaches that you can use to implement data enrichment. As you can see, there is again no one size fits all solution, and you rather should choose the solution depending on the data source you have for the enrichment, and obviously the latency requirements and implementation simplicity. Thanks for watching and see you in the next lesson.